Hi folks, today we are going back to the family of the bedside clocks. In this case the TMS3459BNL. I will let the warn you from the start that is not a good idea to consider it identical to the TMS3450 or the LM8560. It was very significant difference that we will highlight later. We cannot to locate a datasheet. We had to use a schematic of radio models where it was present to verify the necessary connections to bring it back to life. As done previously, the method of extending the pins to convert the 1.78 mm pinout to 2.54 mm has used. The pinout for the display connection is the same as the TMS3450, but the method for implementing buttons has changed and is now based on the common pin that can be switched to positive or negative levels by pressing two buttons. I would like to point out the importance of implementing limiting resistors. Otherwise, pressing both buttons simultaneously will short-circuit the power supply circuit. A significant difference is the pinout used for the power supply. In the TMS3459BNL, the pin 15 is the VSS and the VDD is on the pin 28. This is different from the TMS3450. Please pay close attention to the pinout designations for the power supply, positive and negative. It is important to consider the age of this integrated circuit, as in its time it was common for MOS family integrated circuits, channel P, to use the VSS for the plus and the VDD for the minus. Pay close attention to this detail, is very important. I recommend searching for and watching videos on the channel where this topic is discussed in more depth. The complexity of the transformer model used to generate the necessary power for the circuit is evident. This transformer will discourage any hobbyist. That is why we use a simplified circuit based on the transformer with an intermediate tap, previously used in the LM8560 videos, which works very well for this purpose. This is our circuit to test the TMS3459BNL, and every time the event of the power fail happen, the system return with the blinking of the digits of the hours. To stop the blinking, we can press the adjust of the up or down and the stop of the digits happen. To adjust the clock is necessary we press the button to set the clock and after press the button forward or backward. It's important to refer, as you can see here, if I press the forward, the system do it the skip from the hours and minutes. Okay, this is a little difference between the others kind of the ICs to clock. You see here the blinking of the 50 Hz, but in the direct view is not happen. This happen because the cam captures this blinking. My sector is based on the 50 Hz, and to provide the 50 Hz to my clock, I use a resistor of the 100 kilo ohms connected to the pin 25 of the IC, and is necessary apply a capacitor of the 10 nanofarads between the pin 25 and the VDD. This is important to avoid the skip of the clock. The clock is working normal now, but if I remove the capacitor necessary to the filter the cycles of the 50 Hz, you see the counter now is very fast. Okay? Is necessary provide the capacitor to keep the clock running with a normal timer. Now is normal again. It's very important apply a resistor of the 220 kilo ohms between the VDD and the pin 16. Also provide a capacitor between the pin 16 and the VSS. The connection from the IC to display is exactly the same as 3450, and the display is a dual LED display. This means each pin of the display have two diodes, okay, do it two segments. This means you have two common pins to the cathodes, and please don't forget the connection of the two resistors to make the limit of the current required by each common cathode. I'm not implemented the buttons to control the radio and the sleep and the wake up because it's the same of the others and is not complicated to implement.